right, so let's go over, the first one to overcome this obstacle of having the odd and even numbers, okay? So I'll rewrite it so we have a little bit more room. All right, so let's do a simple chart here. How many phosphorus atoms do we have on our reactant side of the arrow?
4.
4, very good. How many oxygens?
2.
On the product side, how many phosphorus?
2.
And how many oxygens?
4.
All right, so what do you want to start with? I guess let's start with the oxygen because we know that's going to give us more difficulty. All right, so over here we only have 2. There's nothing we can multiply 2 by to get 5. And there's nothing we can multiply by 5 to get 2 without it being, a decimal, which we can only use whole numbers. So what we can do over here is if we multiply our odd number by an even number, then we can have a number that will work for both, right? You guys talk about least common denominators in math class? A little bit?
Yeah.
So that's kind of what we're going to work with here. So least common denominator just means that it's a number that both numbers can be multiplied by to get the same bigger number. All right? Make sense? So if we multiply 5 by 2, an odd number by an even number, how many oxygens do we get?
10.
10. Very good. What can I multiply 2 oxygens by to get 10? 5. And then we change this down here to 10. All right. So now I have how many phosphorus atoms on this side?
4.
4. Very good. Because it's 2 times 2 is 4. All right. And then did I change anything over here to change our phosphorus? No. So do my phosphorus atoms match up? Are they balanced? Yes. Are my oxygen atoms balanced? Yes. So if I were to write a final answer that looks cleaner, it would look like this.
Yeah.
Yes.
Oh, never. Wait, so that 2, right? Didn't that number do 10? So wait, look, so you multiply the 2 right there, right?
The 2 right here. This one?
Yeah, with the 5 and then with 2. Why didn't you multiply the 5 with the 4 over there?
Because this is a separate atom.
True.
So they're 2 different molecules. Over here, we only have one product. So that's why this coefficient affects everything on this side of the arrow, because it's only one product.
So when you multiply that to get 10, did you multiply that big 2 with the 5 right there? Or like that 2 next to the 3 on her?
Here and here?
No, I'm talking about over on this side.
This side.
Yeah.
Over here?
Yeah. You
So
multiply.
this 2 applies to the P and to the O.
Okay. Okay,
Alright.
so why you pick 2?
Because we needed to get this odd number to become an even number. So in order to, what's the question? Because we can't, there's no multiple that is a whole number to make this 5 a 6. So in order to make an odd number become an even number, you multiply it by an even number.
So I could have picked any number.
So you could have picked 4, right? Because that's also an even number. But then you would have, this number would be doubled, you'd have 10 here, and you would have 2 here.
So you had to make sure they add up together, basically.
Right, we need the same number of phosphorus and oxygen atoms to equal this number of phosphorus and oxygen atoms. And you also want your balanced equation to have numbers that can't be simplified. So if you did 4 here, 10 here, and 2 here, those numbers could all be simplified if you divide them by 2.
Alright.
Okay? Good question. Does this make sense now? This final answer?
Yeah.
It's balanced and checks out.